This is StarTalk. It's Cosmic Queries edition. Chuck Nice.
What's happening?
You're always there for me.
That's right, my friend. That's right.
I'm glad you like learning, because otherwise this would be a really crappy job for you.
I'm glad I like learning too, for reasons other than even this. But yes, it's always great.
Your mama would be proud, the school teacher that she was.
That's right. That's right. Yeah, exactly. Maybe that's where I get it from. You know?
There you go.
It's very cool.
So with Cosmic Queries, and occasionally, the bag of Cosmic Queries collects, and sometimes they don't fit into categories. Yep. So we've made a category called No Category.
I like that.
Okay.
Cosmic Queries, no category.
Beyond description.
Yes.
So, all right, we'll see what we got.
Yeah.
We'll just pull them out. So this
here we go.
All
right, here we go. Let's get to.
You got some Patreon members up front?
Always up front with Patreon. Right, let's do it. Thank you for your money, guys. We appreciate you. That's Patreon patrons. Victor Sanchez says, all right, knowing that dark gravity is out there, but we don't know how it got there. Could it be that dark gravity is the residual energy from a dead black hole, as Stephen Hawking had a theory that black holes do eventually die after a very, very, very long time? And that's the end of that question. But
that's an interesting question. Who asked that?
That was Victor Sanchez.
Okay, very good, very interesting question. I think we've had gun questions from him before.
Yes, we have. Yeah, Victor's a regular.
He's a regular.
Yeah, and clearly he's literate, knowing that black holes evaporate.
Yeah, and he did some name drop Stephen Hawking.
And the Hawking radiation and the whole deal. Right.
So let me just remind people, or alert you if you've never known, that black holes evaporate. All theoretical evidence points to the fact that they evaporate. And the way this happens is the energy of their gravitational field is so high that it spontaneously creates matter out of it.
That is unbelievable.
Yeah. Energy and matter are opposite sides of that equation, E equals mc squared. So matter can become energy can become matter. That's how that works. And that's the recipe if you're going to make that happen in your kitchen. So at just outside the event horizon of a black hole, what you can make is spontaneously fabricate particles from that energy field. Wow. And when you make particles out of energy, you make a particle and an antiparticle.
Right.
That's the rule. That's how the universe rolls. And they fly in opposite directions. Okay? So one falls back into the black hole, the other escapes. It turns out that when the black hole loses energy from its gravitational field, it's the same thing as it having lost mass. Same thing.
Wow.
So in fact, the black hole weighs a little less for this. And this just keeps going. It's very slow and it's not very efficient. Take a long time, but eventually the entire black hole dissipates back into space.
And it only takes 3 trillion years.
Actually, a little longer.
Really? Wow.
The black holes in the centers of galaxies, if you run the math on those, it'll take about a Google years.
Oh my God.
Yeah. Very long time.
That's a long, okay.
Yeah. So there's a long tradition of those interested in my field to look in the very distant future of the universe. So there's a colleague of mine who wrote a book, The 5 Ages of the Universe. Okay. And his last name is Adams. You can look it up. And he, in it, there's the age of like stars. Okay. Mm-hmm. Fine. All right. Well, what is another age? Well, when all the stars are dead and all you have are black holes, then the only energy coming out is the black hole evaporation. Right. So then you have this era of just black holes evaporating. All right. But that's a way long in the future, and that takes a really long time, but nothing else is happening. Right. So you get to label it by that according to what the primary thing that's going on over that time. So relative to that period in the universe, the age of stars is just a blip. So the question was, could the dark energy, the dark gravity, be sort of the spirit energy left over in the field of a black hole? I think that's the question. And the answer is no.
Okay. And there you go, Stephen. Thanks for playing. The answer is no.
So no, here's the thing. If you run the history of the universe back, whatever it is that is the dark gravity, the dark matter, whatever that is, it cannot physically interact with ordinary matter. Because if it did, it would completely change what the universe looked like. So it has to have gravity and not interact with us. And a black hole
does both.
Does interact with, black hole has gravity.
Right.
But the particles that evaporate out of it, we interact with those particles. Those
Right.
are like this regular matter that comes out. So no, so you can't appeal to black holes for that. No.
Exactly. Sorry.
Yeah.
You can't appeal to a black hole for anything. They are
You
so
tried.
unreasonable.
You could try.
They're so unreasonable. Just like, bro, why do you got to take everything? You're such a taker.
You cannot reason with. I should tweet that. Never try to reason with a black hole.
Cannot reason with a black hole. All right. So, based on this is just out of curiosity, based on what you just said. So now, since we cannot interact with it, and it does have gravity, so this is this force. Is it possible that this force?
Right. I want to be clear.
Go ahead.
You can interact with this stuff gravitationally. That's
Right.
how we
Exactly.
know it's there.
That's right.
But this whole other level of interaction that I'm talking about is why we even exist. It's the fact that the material can come together and make atoms and molecules. And that's why you're this physical thing that I can touch. And
Right.
you're a physical entity that is matter collected doing other interesting things as a collected unit. What we call dark matter or dark gravity has no such properties.
Right. Because and that's why we don't know what it is, because it doesn't have those.
Correct.
We don't know what it is because it doesn't.
It doesn't interact with light or the energy or electromagnetic forces.
Right. So now, is it possible then that it's kind of a platform that predates all of us? And when I say all of us, I mean the universe.
Yes. Well, it was there from the beginning.
Right.
So I don't know that it predates us, but it co-dates us.
Okay.
And here's a way to say it. Its presence shaped what matter did afterwards. So in that sense, it pre-organized us.
Pre-organized.
Yes.
Wow.
Yes.
Wow.
So here it is. So it'd be like looking at an ocean at night, at like late twilight, and you see sort of the white caps on this. Like maybe it's a gently moonlit night. If all you could see are the white caps, you say, "Oh, the ocean is just these little white caps," and then the sunrise is like there's a whole ocean there.
Right.
Okay, and you realize the white caps are just these little. It's evidence of there being water, but it is a small fraction of the total water that's there. So we spent our whole lives finding galaxies in the universe, thinking that was the material representation of matter in the cosmos. Turns out, no. The galaxies are found where dark matter has collected them.
Right.
There it is.
That is
So in some galaxy clusters, there's 100, 1,000 times more dark matter than regular matter.
Right. Wow.
So we are the froth on the waves.
Oh man, God, can't we be the foam in a cappuccino? I don't want to be the froth on a wave.
Foam on a cappuccino. That's good. That's better. It'd be better if an Italian had come up with it. Then maybe that's what they.
That's what it might have been. Cool.
It totally would
All
have been
right.
better.
Hey, Victor, great question, my friend.
What was that song from? Was it the 1970s? All we are is dust in the wind.
All we are is dust in the wind.
All we are is froth in the waves. Yeah.
I'm so glad they didn't write the song that way. All we are is froth in the waves.
No,
all right, here we go.
All we are white caps. No, that was all we are white caps in the open ocean.
Okay. I like Dust in the Wind a little better.
Okay,
I'm gonna go with Dust in the Wind.
Because it had a beautiful tune with it. But
yeah, that's what you need. That's what you need now is a melody. Yeah. All right. How about Glenn from Glenn? Glenn's like Cher. Glenn does not need a last name.
It's just Glenn.
It's just Glenn. All right, Glenn.
The problem is there's a zillion Glens out there. There's probably only one Cher.
Right. I feel bad if your name is Cher and you got to have a last name. All right. So Glenn says, How can we tell when an area is obscured by a black hole or whether it's just an empty area of space? How much of our view of the night sky is obscured by objects such as a black hole?
All right, so space is mostly empty.
Well,
Okay? I think we said on a previous broadcast, I gave the example of how empty space
oh
is.
my God. And it's
I'll do it again right here.
mind-boggling.
You ready? Right.
Mind-boggling.
So you look at a sentence printed on a page, and then the sentence ends with a period.
Right.
I think in Europe they call it a full stop, but there it is, a period. If the sun were the size of that period, and everything shrunk to match that up, the next closest star is 4 miles away.
That's unbelievable.
Yeah.
I mean, seriously, every time I think about
That's
it. Right.
So when you look
I mean, you got to imagine that scale and the distance of 4 miles, because we all know what 4 miles is.
Right,
and we all know, what a
6
single
kilometers, right? And we all know how small a period
is.
Right. So what I'm saying is, as you look out into space, your sight line is not accidentally bumping into anything. Okay. It looks like the night is filled with stars. Well, because you're finding the stars to look at. If you just close your eyes and like threw a dart, it would just go here to the edge of the universe. Yeah, hit nothing.
Wow.
It'd be all air, all space.
All space.
So no, the space is not crowded so that things are blocking your view. You know what does block your views? Huge gas clouds. They block your view.
Right.
Because they're huge. They're manifold times larger than the solar system. Whole star clusters are formed out of such gas clouds.
Right.
So they're huge. And radio waves pass right through them, which is why radio waves is the band of choice for aliens. If you want to talk to aliens or you want to hear what message they have, they probably know, if they're smart, that radio waves pass through all the obscuring dust and gas in the galaxy. So you would use that. If you used visible light, then it would just get absorbed or scattered and you wouldn't be able to communicate. Right. So radio waves will go through, but ordinary light, visible light, no. So gas clouds can block your view. In fact, the Milky Way at night, there are these dark lanes, and people thought, that's where 100 years ago, that's where there are no stars. Maybe we see through the galaxy to the rest of the universe. No, they're dark clouds that are actually obscuring your view from what's behind it. And that took a long while to figure out.
Wow.
Consider this. In Australia, the native Aborigines, like everybody else in the world, they had cosmic lore about what they see in the night sky. And to them, they identified not the brighter areas of the Milky Way, but the dark areas. They gave meaning to the absence of light.
Wow.
Rather than to the presence of light. And in fact, one of the largest dark lanes is called the Great Emu in the sky. Very, very local fauna.
Yeah.
And if you look at it, it's got a tall neck and it's got a beak area. So it's an emu. So it's an interesting distinction between a Western concept that something has to give you light for it to exist as a thing, and in Australia, where the absence of light was the thing itself. So
they're working in negative spaces. That's cool.
Yes, as the designers would say.
Yeah.
So now, how would you know a black hole is there? Because it's completely distorting all of the imagery surrounding it.
Right.
Because the fabric of space and time doesn't send light in straight lines. It curves, and you will see this. So if you're traveling through space and all of a sudden your images start taking these circular distorted patterns, back the hell out.
Right, exactly. That's a detour sign.
That's a detour sign.
That's the detour sign of the cosmos.
There you go. Get the hell out of the path. So yes, you would know black holes if they were in front of you.
Cool.
Yeah,
all right.
Yeah.
So let's move on. Let's take one more Patreon patron. This is Travis Mansfield, and he says, do you think SpaceX is just a front to a larger Armageddon conspiracy? Like maybe we already know that a huge asteroid is going to hit Earth, and this is our only hope.
I'm not authorized to comment on that. Yeah. Next question. All right, Chuck, we got to wrap it up. but that's a really good question. And see what I did there? I'm making you wait.
Little teaser. Little teaser.
Commercial. Yeah. So when we come back, more Cosmic Queries Galactic Gumbo Edition. We're going to talk about, we're going to touch on conspiracy theories when we return. We're back. Cosmic Queries Galactic Gumbo Edition, which is a category unto itself that Chuck invented. Galactic Gumbo.
Guarantee.
Yeah,
wow.
Questions are completely random out of this bag. So we left off with a cliffhanger on conspiracy theories. So Chuck, read the whole question again.
All right.
So we're on the same page here. Go.
Okay, cool. Travis Mansfield, do you think SpaceX is just a front for a larger Armageddon conspiracy? Like maybe we already know that a huge asteroid will hit the Earth and Martian colonization is our only hope. Boom.
So here's the thing. As you know, we upload billions of photos and videos to the internet every day. Let's just start there.
Okay.
Second, a conspiracy requires many people participating in a lie on a level where the temptation to let others know is somehow removed from people's behavior. And so it would require the government to successfully pull this off. And anyone who's worked for the government knows how inept they are at keeping secrets.
Yeah.
Or doing anything organized at such a level.
Right.
So I think the urge to want to believe that conspiracies are driving everything that's happening around us needs a deeper psychological explanation that we don't currently have.
Okay.
So ask the psychologist why you want to believe there's a conspiracy. That's really what we should be doing here. Not asking, I think there's a conspiracy, convince me that it isn't.
Why do I think there's a conspiracy is the real question.
That's the question.
Gotcha.
Exactly.
So Travis, there's your answer. We're going to send you the number of several therapists. And have at it, my friend. Have at it. There's a couple teledoc.
Specialize in it.
Yeah, there's a couple that you could do through Zoom, and it's listen, it's a good thing, my friend. It's a good thing.
So at some point you have to ask, why don't you completely flesh out the conspiracy? Just put in all the details you need.
Right.
Okay. It would mean the government has discovered an asteroid that's going to destroy us all.
Right.
And they're keeping that a secret. And everyone else in the world who has a telescope who can detect it somehow is missing it, but only the government caught it.
Right.
Then the government is secretly negotiating with SpaceX to build spaceships that we can then, an ark basically, to collect maybe 2 by 2 of only the chosen ones in the world so that they can go to Mars as we terraform Mars, because we've been practicing this with the contrails of airplanes for the last several decades. So all of this comes together. Now, just think that through, and how many people that involves, and how many people would have to keep that a secret, okay? Just put all that together, and then ask yourself,
is that viable and feasible?
Isn't it easier that just...
Tell us. Isn't it easier to just tell us we're going to die?
No. Isn't it just a simpler explanation to say, no, the government doesn't have this kind of secret information about the night sky because anyone else could then have access to it, and there's no way they can keep that a secret. Right. On top of that, we just have someone as a modern day Thomas Edison, and he's building and inventing stuff.
Exactly.
And it's great, and we all look forward to whatever the next, and he's very transparent about his successes and his failures. Whole YouTube compilations of his rockets that blew up on the launch pad.
That's so true.
None of this sounds like a secret to me. That's all.
Okay. You know what? That was an extremely salient and thoughtful answer to give to this question. Because, see, and this is why you're an educator. Because me, I'm just like, man, shut up. And I don't mean that to you, Travis. I'm not talking to you. It
requires a little more patience.
Yeah, I'm not as patient as what I'm saying. Come on, and let's, but no, I think it's good that people heard you kind of walk through, because what you just said is applicable to any conspiracy that you might subscribe to.
Correct. And my favorite version of these is, I think I saw it in a meme, but I'll just retell it. So Neil Armstrong and Buzz Aldrin of Apollo 11 fame agreed to fake the moon landing, but they really wanted to be as authentic looking as possible and urged NASA to do it on location. And NASA agreed.
Oh my God, that's insane. I love it.
So there you have it.
Okay.
All right, Chuck, next question.
All righty. Let's go to Belt-Fed Joe.
Belt-Fed?
Yes.
Okay.
Belt-Fed Joe from Tucson, Arizona.
I don't even know what that means.
I don't either, but apparently Belt-Fed does. And
or his mama did.
yeah, somebody knows the deal. And
not us.
Yeah. And he says that Arizona is the astronomy mecca. Now, I thought it was New Mexico, Neil, but he says it's Arizona. Is there an astronomy mecca?
Yeah, I would say Hawaii. But,
okay.
Yeah, because they have a 14,000-foot mountain, the Big Island, where you're above clouds, and we have telescopes there. And,
okay.
Yeah, so if there were one,
now,
it would
is that
if I had to pick a state where you say the most significant astronomy happens,
right.
Arizona would be maybe a close second.
Close second.
Here's Arizona's claim to fame.
Go ahead.
Ready? Okay, in Tucson, Arizona,
right,
the nearest important city to an observatory called Kitt Peak.
Okay.
They have a relationship, Kitt Peak Observatory and Tucson. Kitt Peak said, in order for us to continue to do our science, you can't keep making your city brighter at night because you'll interfere with our observations. So let's work together to reduce the nighttime illumination. Because it creates a sky glow and interferes with your ability to see the stars at night. So they got together, and all the streetlights have these sort of caps on them so that the light only points downward. And by the way, if it only points downward, you don't need half the wattage you previously had to illuminate the sky. Think about it. If you're flying over a city in an airplane and you see a streetlight, somebody is paying to have that streetlight send photons to you in the sky in your seat in the airplane. What the hell good is that? So this is very sensible recommendations, which saves the town money, saves the astronomical dark skies, and this set of ordinances, the dark sky ordinances, have been copied by many other cities around the world.
Well, there you go, Belt-Fed Joe. You may not be the astronomical mecca, but you certainly are super important. That's cool.
Yes, and New Mexico also has quite a fun suite of telescopes.
Right.
So both together, I would say.
All right.
And why? Because there's a lot of desert climate within them, and you don't put a telescope in a rainforest, right? You put it where there's no clouds or a minimum of clouds. And New Mexico, Arizona, Southern California satisfy that.
Okay. All right. Yeah. So this is what he says. Are the sizes, masses of planets proportional to the distance between planets? Is the composition a factor? Are there any exceptions? That's
a great question, because you might ask,
right,
if I have a lot of space between me and my neighboring planets, did I eat everything?
Right.
All right. And would I then be the biggest planet?
Right.
Okay. You can think about it that way. There's some truth to that, perhaps. Jupiter's big. It's the biggest planet of them all.
Right.
But Saturn has more room between it and Jupiter and it and Uranus than Jupiter has between it and Mars and it and Saturn. So it's not a direct one-to-one relationship.
Right.
So, because in fact, Saturn is twice as far away from the sun as Jupiter is. And then Uranus is twice again as far away, right? So There's way more space out there, but it doesn't always mean this. And by the way, when you look at early modelings of the formations of the solar systems, stuff it's a shooting gallery. It's mean back then. Stuff is slamming in, and
it's a pinball machine.
It's a pinball machine, but where the balls stick together, where they either stick together or blow each other apart, right? one or the other.
Worst pinball game ever.
So when we do this. It's when you run those simulations, you find many objects that might have hung around and collected more material, competing with the material you want to collect. It gets ejected from the solar system entirely or sent down to plunge into the sun and vaporize. So it doesn't precisely work that way. But I say by and large, if you have a bigger sort of gravitational zone, we would expect you to be bigger. But it's not a perfect relationship.
All right, cool. Nice question. Yeah, and by the way, he ended by saying, Tyson Nye 2020.
Okay.
Might be a little late for you to get on the ballot, but still, there's the sentiment, okay?
All right.
There you go. All right, let's go to Michael G. Thompson from Facebook. And Michael says, if I was on an alien planet many light years away, but I had a telescope, a powerful telescope, powerful enough to see people on distant planets, what would be possible based on how far away my alien planet is? Would it be possible for me to see actual Roman battles taking place if I were looking here at Earth?
Yes. If you are at the distance in light years from Earth that corresponded to the time in the past that those Roman battles took place. So when did you have the Colosseum? Let's just say 2,000 years ago. The time of Jesus, right? Because that's the whole storyline there.
Right.
And so find a star 2,000 light years away, park yourself on a planet there. You have to do that now, and get a nice big telescope, aim it towards Earth, and you will see the Roman Colosseum in real time.
Wow.
Well, delayed time.
Right, exactly.
Delayed time.
In your real time,
correct.
In their gone time.
Right. And there's a galaxy, I forget, is it M101 or M100? There's a beautiful spiral galaxy that's 65 million light years away from the Milky Way.
Gotcha.
So I want to go there and look back.
Right.
What do I get to see?
The beginning of everything here.
65 million years ago?
Well, not the beginning of everything, but the beginning of what we, this
65 million years ago?
Wasn't that the dinosaurs?
Yes, thank you.
That's what I said. The beginning of everything now. The beginning of this crap, I called it. I forget
that's what you'd write on an exam trying to get partial credit because you didn't remember it was dinosaurs.
I said dinosaurs, but anyway, I was trying to think.
After I wrenched it out of you.
No, I was trying to think which scene it was. Like, is it the Pleistocene? That's what I was trying to think of.
And they got a little bit of a renaming, so it's no longer the KT boundary.
Okay.
But there's a more accurate, less memorable name that it's been given.
Okay.
But the point is that boundary, the 65 million year ago boundary, an asteroid struck Earth, took out the dinosaurs.
That's it.
Wreaked havoc. You bear witness to that.
Right.
From this galaxy 65 million years ago.
That's so cool. And you couldn't even say, look out. You couldn't even.
What? Oh, you can't warn anybody.
Can't warn anybody.
Stuff already happened.
You got to sit there and watch it because you're watching a rerun. Damn,
it's already happened.
A rerun.
And so the point is, you can't go there from here to see your past.
Right.
Well, no. So you could if you could beat the light beam.
Right. So So let me ask you this: what you just said. Now that sparks in me this. Okay, you can't get there, but if you were already there, you could see the past. So correct. Now that says, all right, why is it then that we can move up and down, back and forward, left and right on this axis, right? But we can't move back in time. If theoretically, like we can't, not even theoretically, we can't do it. You got to beat the light in order to do it.
Let me re-ask your question. You're saying if time is a coordinate like all the other coordinates,
right, and
we can move back and forth in X, Y, and Z, why can't we move back and forth in time?
Right. Because,
is that your question?
Yes.
Yes. Okay. So it is indeed true. We are prisoners of the present, forever transitioning from our inaccessible past to our unknowable future.
Now, see, I asked you a question and you done turned it into a doggone poetry slam.
No, just saying.
I mean, that is beautiful what you just said. It's gorgeous, but yeah.
So it would be very interesting if you could step out of your timeline and then rejoin yourself.
Yeah.
Either in your future or in your past. But that kind of would imply that your timeline is predetermined.
Oh, okay.
In the same way the coordinate is
right, because if that coordinates are definitely predetermined.
If I step over there,
right.
That's been there. It's waiting for me to step there.
Interesting.
Right? It doesn't invent itself as I arrive.
Right.
It's there. Okay, so
now
wait, hang on. We got to take a break.
Oh crap, man! Because I gotta know this. Because you bring up predetermination, and then you say we gotta take a break.
Time for a break.
You're worse than my therapist. Just when I'm about to have a breakthrough, he's like, "And that's all we have time for today."
All right. When we come back, more Cosmic Queries, Galactic Gumbo Edition. We're talking about, I guess, in this moment, time travel. When we return. Chuck, have you calmed down? Your therapist on speed dial?
Exactly.
So you asked a very important question. Why can't we move on our time coordinate?
Right.
If it is what the physicists say it is, it's just another coordinate.
Exactly.
Like
right.
No, it is a little different because we are prisoners of its present.
Right.
That's why it's a little different. But if you could step out of that coordinate, yeah, you could go backwards.
You could go backwards and forth. So then you bring up, this is more philosophical than it is, physics. But I'm going to ask, speaking of stepping out, so that connotes, infers.
If your mama were here. We infer. It implies.
It implies. Correct. Okay. Right. I was about to say.
Was your mother an English teacher?
Yes, she was. What I should have said was, I'm inferring. Yes, that's what I should have said. Mm-hmm. But because I'm not sure if it implies, but I'm inferring that would connote the unfolding of time as opposed to the predetermination of time.
If what?
If we lack the ability to step out of these coordinates and look at our timeline, thereby being able to identify a point in the past and go back, does that mean that being a prisoner of the present means that the present is not determined? Because there are some people who believe in predetermination.
Yeah, maybe
yeah.
I don't know.
Oh, okay. Because that's a crazy thing that you just brought up.
What are you suggesting that if you could step out,
right,
it would require that it's predetermined?
Yes.
So the fact that we can't step out is the evidence that maybe we have free will.
And it's funny because when you say it that way, free will, I think brings in a completely different philosophical discipline. But I look at it more as a present unfolding, more so than I look at free will, which means that we have some influence, okay? Maybe not free will, because that's so philosophical, but we have some influence. Like,
Yeah, the problem is if you rejoined yourself in the past and you changed something that prevented you from stepping out of your future, then you could not have rejoined yourself in the past.
Damn.
So there's it's a causality conjecture violation,
right?
Which Stephen Hawking had proposed, that he suggested there will never be backwards time travel, and one day we will discover why. And it's a time protection conjecture.
Wow.
Where because you can't go back in time and prevent your parents from meeting. Then you would have never been born to have gone back in time to have prevented your parents from meeting.
Wow.
So you've got to avoid those kinds of paradoxes.
Gotcha.
And it may be that there's a law of physics that prevents it. We don't know.
We don't know.
By the way, this brings me to Superman, if I may.
Uh-oh. I always love when we talk Superman, so go ahead.
Okay. I've said this in some other videos, but here and now it's relevant. Okay. I got a call from DC Comics some years ago.
Okay.
And they wanted to have Superman visit the Hayden Planetarium.
All right. Okay. By the way, just another afternoon in the life of Neil deGrasse Tyson. Hi, Neil. Well, hello. This is DC Comics. Just want to know if Superman can drop by. Okay. All right. Oh, that's great.
You could have visited too. I didn't, nothing against that.
Oh, that is so good. That is so good. But go ahead. So they wanted to know Superman could visit the Hayden Planetarium.
And I said, they wanted my permission. I said, sure. And then they said, well, do you mind if he meets you in this? And I said, sure.
Okay.
Okay. Of course we can meet. And then I asked what the storyline was. The storyline was, he wants to use the observing capabilities of the planetarium to look back at Krypton to see it get destroyed.
Gotcha.
Okay. Because he did a calculation to realize that the light from that episode, which is when he was born, was finally reaching Earth.
Right.
And so he wanted to witness this. So I said, all right, wait. All right. I said, wait. You can't just do that unless one of two things happens. Either he traveled here in a wormhole.
Okay.
Beating the beam of light.
Right.
Okay.
Because you can't go faster than the speed of light, but you might be able to get places faster than the speed of light.
What? So he has to tunnel through space in some kind of way.
Right.
And we do know that he arrived in, Moses style in a basket.
Right.
Not much older than when he was launched.
He shall deliver my people.
Okay, so
go ahead.
And infants, you can tell when they've aged weeks and even months. Right. So here's an infant. It's really no older when it arrived than when it was launched. So it got here basically instant, or it traveled at the speed of light and didn't age.
Right.
But if it traveled at the speed of light, then the speed of light of the dying civilization would have arrived at the same time he did.
Right. So thereby rendering it impossible for him to look back at his past.
So I told them it's got to be a wormhole.
Gotcha.
And they said, oh, great. And they're taking notes and they're writing it down. I said, fine. So we do this. And then I said, well, how old is Superman? Because this will depend on how far away the star is from Earth. Okay? Because if he was launched when he was born, at whatever age he is now, that's how many light years away the thing is.
Right.
Okay? That's how that works.
Right.
So they said he's eternally in his late 20s. So I said, okay.
By the way, Neil, so am I.
So I asked him, I said, do you want me to find you a star? A red star like Krypton. Do you want me to find you a red star at about that distance? And we could just declare that to be Superman's home planet. And they said, you could do that? I said, yeah, there's a bajillion stars out there. Went to the catalog, found a star, found a red star 27 light years away, and boom, there it is. So now in Superman canon, there is this star, an actual star in the night sky, which is where he came from. Wow. And he comes and then he observes it. And he's very sad because he knew it happened intellectually, but then he sees it as we recreate the image at the Hayden Planetarium. So that's actually done in Action Comics 14.
All right. That's a really cool story. Okay.
Action Comics 14.
Action Comics 14. I got to give it to you, man. That is a really cool
And by the
story.
way, I was a little chubby then. I'm a little chubby now, but I said to the illustrator, I said, if it makes no difference to you, could you take off a few pounds? I just asked. And they said, Dr. Tyson, this is the world of the comics. Everyone looks good.
Yeah, we're going to give you a six-pack. Are you kidding me?
Yeah, so I'm there standing poised as I did in my youth.
All right.
And so, yeah, it was fun. If you want to find it, Action Comics 14.
All right, that's super cool, man. All right.
It's in there.
I guess we should move on, even though,
I guess so. All right, next question. But
okay.
that's precisely related to that question.
Yeah, it was.
Can you see something in the past?
Absolutely. I love it. All right. Portuguese for Americans says this. Portuguese for Americans, he says.
Portuguese.
He says, what would happen if something made Earth rotate in the opposite direction? Speaking of Superman. By the way, I did not plan this. I swear to God, I did not plan this. I just happened to look down, and this was the next question that jumped out. I didn't even know it was coming up. And he says, as Christopher Reeves did in the Superman movie, I can't believe that just happened, but that this is kismet. It must be meant to be. So go ahead.
Wait, what's the question?
Oh, yeah. What would happen if you actually did rotate the Earth backwards? What would happen to Earth?
Okay.
So you stop us. First of all, you stop us, and then you start us in the other way. What happens?
Okay. So
We all
First,
die.
you don't want this to happen. Yes, we'll all die.
We all die.
That's the answer. Next question.
I was joking. I really don't know what happens. What happens?
It reminds me, I recently tweeted about, I do tweet this every 5 years or so. You know, if you took all the veins, arteries, and capillaries out of your body and tied them end to end,
Okay.
you would die.
Okay, that's funny. All right, that's a funny joke, though, by the way, man.
So I put that out there.
I like that.
And then people get all serious with it. You realize you would die before you had the chance to tie them end to end. People try to analyze it.
Well, now, welcome to my world. Your premise is untenable, sir. Okay. So anyway, let's just say you slow us down to a stop, and then
so
you go back the other way.
It's worse than that. Okay.
It's worse than
Have you
that.
ever been going fast in your car
Yep.
and someone puts on the brakes
Yep.
in a steady slowdown, but it's you put on the brakes steady. In a steady slowdown, you feel yourself leaning forward the entire time the brakes are applied.
Thank God I have the active restraint seatbelt, which actually grabs me and pulls me back because you're still going for
You're still feeling
you're still
this
feeling
forward.
that forward motion.
Okay. While the Earth is slowing down, everyone will lean east.
What?
Okay?
All right, this is cool. All right.
Everybody will be leaning at exactly the same angle east, depending on how quickly we slow ourselves down.
Right.
Okay? So what you'll think of as vertical will be a lean at that point. Okay?
Right.
And you'll stay there until we stop. And as we come to a stop, then you'll stand erect again. Okay? But then we're not rotating. So one side of the Earth will always face the sun. Well, this didn't last that long, right? Because he sped
Right.
the Earth
He
up
sped
again.
it's right back.
Okay, so that's fine. Because otherwise you get very unequal heating of the Earth, and that could wreak havoc climactically. But then he quickly sped us up and had us go the other way. So then you lean, because now you were decelerating, now you're accelerating. And anytime there's an acceleration, you're going to feel that as a sort of a constant sort of lean, okay? And so let me get it straight. So if you'll actually continue to lean east, is that right? It was accelerating this way. Yeah, so you'll continue to lean east. Because the same force that slows you down and speeds you up in the other direction is the same force operating the whole time.
Wow.
Okay?
Okay.
So, in other words, he's pushing against the rotation of the Earth.
Right.
And you lean against that, but he just keeps going through zero and rotates us back the other way.
Right.
So that same force does that. You'll feel that lean, but then he has to stop that and then send it back the other way. So then you'll all be leaning the other direction until we're back to our normal speed. But nothing would have happened to the timeline. There is no backwards time. That is nothing.
Now, what about the things that are not the physical characteristics of the Earth that are not nailed down? Like the oceans and stuff like that.
Sorry. So all the oceans would slosh up. Yeah, so the Atlantic Ocean would begin to slosh up onto Europe and Africa.
Oh, okay.
And the Pacific would slosh up onto, thank you, I forgot all about that. Because the ocean is not stepping on with friction to the Earth. It'll just slosh with it. Yeah, so you'll basically flood all the continents.
So, okay. So, all right. So there you go. All right.
Well, it depends on how abruptly
So basically,
you do
Superman killed everybody on Earth when he did just to save Lois Lane. Who, by the way, in the words of Donald Trump, not that hot.
Look, I'm told by people in the know that there's a reason for that.
Okay, what is it?
Because if Lois Lane were a beauty queen,
right,
then you, as an average person, would not have access to Superman. Because if you're not as beautiful as the singular beauty queen.
Right.
So they drop her down a few notches closer to sort of your average person. And
now,
then if you're an average person, then you can say, oh, I can
bag Superman. I'm hot enough for Superman. I'm hot enough.
You say, well, if Lois Lane can do it, then I can do it.
I can get him.
No, I can get him. Mm-hmm. That would be totally the mindset.
Right, exactly. Oh, that's too funny.
So now the problem is, if he had stopped it abruptly, then we'd all fall over and roll due east 800 miles an hour.
Oh,
and then
sweet.
That would be the end of anything that's not attached to the Earth.
Nice.
Yeah. So, but the fact that he did it slowly means there's a chance you could survive
Right.
If you have a boat.
Yeah, if you have a boat.
Chuck, we got to end it there.
Oh, crap.
No, I know. I'm sorry. But it was fun.
These are so much fun.
Galactic gumbo. And since they don't fit a category, they're their own.
That's why.
They have their own flavor.
I think that's why they're so much fun, because it's just you just never know who's going to ask what.
We got to do more. All right, Chuck. Always good to have you.
Always a pleasure.
Tweeting at Chuck Nice Comic.
Thank you, sir.
I don't follow many people. I follow you.
Well, thank you. I follow you too. To the end, to the ends of the earth.
To the ends of time.
Even when Superman is sloshing it full of water.
You got it. StarTalk, Cosmic Queries. Neil deGrasse Tyson, as always, keep looking up.